Good afternoon. Being the last speaker, I hope I will keep you engaged. I'm Hua Dong, coming from Brunel University. I belong to the Brunel Human Design Institute, where I lead the Inclusive Design Research Group. So what is inclusive design? We take a human-centered approach to design. You can regard, human is always in the center of any programs. They have basic and higher level needs. And our design solutions or research outcomes should address people's basic needs, should be useful, usable, desirable, and sustainable. In order to achieve this, we need to involve users in the process. We need to work with different stakeholders and also engage with different disciplines. So today's talk is really focused on the multidisciplinary aspect of inclusive design. So the project is called Data Mix because we mix people from different disciplines and mix different types of data. And that is I would call a multidisciplinary study of data visualization sponsored by the National Endowment for Science, Technology and Arts. So these are the people who collaborated in the project. From the left side, Elizabeth is a lecturer in physics, and Melissa is a biochemist. Paul works in the University of Bath, Department of Architecture and Civil Engineering. Nick is a digital musician and he lectures in the University of Sussex. I lecture in design, and Paul Pewick is a computational linguistics. And Gordon Vara is a chemist. He works in the University of Glasgow. We all share one common interest, which is data visualization. That's why we come together to do this project. Because we all come from different backgrounds, it's difficult to find one common methodology. We think the best way to maximize the multidisciplinary collaboration is through interaction. So we decided to organize a series of exploratory workshops. So the first workshop, we started to look at data in different disciplines and what tools people use to represent data in different disciplines. Each of us prepared 20 slides of data and typical tools in our own discipline. And you can see from this representation, data in different disciplines really mean many different things. And we also analyze in each discipline what are the good examples of data visualization and what are the bad examples of data visualization. This is an example by Melissa, who is a biochemist. This is, in her view, a good data example, data visualization example in biochemistry. And the other one from the same field is a bad visualization. It's quite easy to understand why it's good or bad, although the data can be very different. The second workshop, we started to look at processes and criteria. If you say this is good data visualization, what criteria you are using? So what we do that? So the first workshop, we still work in our own discipline. The second one, we start to work on one common data set. So we select one large data set. Nobody knows the context of the data. We are just asked to visualize the data using our own tools, familiar tools. So you can see from the first row, those are the posters each of us developed. Although it's the same set of data, each person visualizes it in a different way. Some people use cluster analysis, some people turn this data into a dialogue, some people even produce a 3D model out of it, and some people make a piece of music from it. And then in the workshop, we started to look at each different methods and started to look at the pros and cons of each of them. You can see from those colored post-it notes. Some said this is good, the other aspect is bad. And the third row is from the workshop. We started to analyze what are the important criteria, because each of us represented in a different way, and we are viewing other people's data. So what in our view is good criteria and how we rank those criteria. So that's a very preliminary exploration of the data visualization criteria. And I think find interestingly, although we use different methods in visualizing the process, since there's a common pattern, we all start with raw data, and then we process data, and then we interpret it. So in processing data, we do several activities. Those are, we either remove some noise, we convert data from this format to another format, sometimes we cluster, we remap, we create new data from it. The result is you can have 2D graphs, you can 3D plots, you can change of modalities from one type of numeric data to sound data to dialogue to, you can even add color or animation to those data. This is just a visual representation of the whole common process. Then we looked from our own team, what are the researchers' criteria in judging good data visualization. Here is a visual representation. The bigger the size of the text, and this is more important. So you can see from here, from data researchers or developers' viewpoint, what is important is this clarity, purpose, complexity, context. So for data developers, all of these are important because it's almost like a sense of success if you can visualize complicated data successfully. But then we also look at how users, data users, what is their criteria of judging good data visualization. We found their criteria, the first one is clarity, but similar to the professionals, but the rest is, ease of use, simplicity. So here you've already seen there's two different types of views from data developers and data end users. Although we both think clarity is important, but on other aspects it's different. That is because the start point is different. For data developers, it's more important to represent the data, but for users, it's more about making sense of data. These are some preliminary findings from the first two workshops. So there's a lack of inclusivity in data communication. There's different viewpoints from data developers and data users. Clarity is regarded as a key criteria for data visualization, and although people use different tools and they process different data, there is a common pattern of process. And there's a need, we think, to increase the data visualization. There's a need for multiple modalities. Then the third workshop, we started to focus on, is there any common methodology for these different disciplines? We get together not only the researchers, but also we invited users from different communities. We developed many different methodology frameworks. For example, this one, it's differentiated data developer and users, but both of them will be interpreting data and communicating data. And another format is data could be used internally or externally. So this representation didn't think about whether it's data developer or the user, but firstly, we generate a research question, and then we can internally use this data, and then we represent it to the external environment. The workshop took place in the winter, so when we went for lunch, it has snow. Somebody has the idea of why we don't make a visual representation of this as a data representation methodology. You can regard as snow as raw data, and then snowball is your process data. That is handed over from a data developer to data user, and is open to discussion. You might use certain tools. For example, in this case, you might use a glove to make that ball, but what purpose that ball is for the user is totally up to the interpretation of the user, data user. So the project is finished, and we produced a book which is freely downloadable from this website, www.datamix.org.uk. I would like to take this opportunity to introduce a current project which is relevant to data visualization. This is a PhD research sponsored by Ordnance Survey and Brunel University on improving geospatial data usability. The PhD researcher is Adam Strand. I didn't see him in the audience. I'm his supervisor. In his first year, he has conducted literature review, and this is key themes for geospatial data usability. So who are the key authors he interviewed, and also he looked at this usability evaluation methodology, because data usability itself is relatively new, but usability as a topic, there's loads of publications and there's a lot of methodology out there. We can learn a lot from existing methodology and then adapt them and apply them into this specific data usability field. He's currently conducting expert interviews to identify specific issues relevant to data visualization in the geospatial area. So anybody in the audience who's interested in this research, please do talk to me later. Yeah, that is my contact details. I finished earlier. Thank you very much. I belong to the Brunel Human Design Institute, where I lead the Inclusive Design Research Group. So what is inclusive design? We take a human-centered approach to design. Good afternoon. Being the last speaker, I hope I will keep you engaged. I'm Hua Dong, coming from Brunel University. Basically, should be useful, usable, desirable, and sustainable. In order to achieve this, we need to involve users in the process. We need to work with different stakeholders and also engage with different disciplines. So today's talk is really focused on the multidisciplinary aspect of inclusive design. So the project is called Data Mix, because we mix people from different disciplines and mix different types of data. And you can regard human is always in the center of any programs. They have basic and higher level needs, and our design solutions or research outcomes should address people's